Now here f of x is given to be greatest integer function of x, and g of x is maximum of x and minus x, and h of x is a composite function f of g of x, and we need the derivative of h at minus 2. Now if you look at this function, f of x is given to be greatest integer function of x, but if you look at the g of x function, which is defined as the maximum of x and minus x, this is nothing but our mod x function, right? This is an alternate definition of mod x. Now we have g of x as mod x and f of x as greatest integer function. Can we define h of x now? Yes. The function h of x, which is defined as f of g of x, is nothing but the greatest integer value of mod x. Now before we proceed to find the derivative of h of x, first let us try to draw the graph of h of x. When we consider the Cartesian plane with 0, 1, 2, 3, similarly on the negative side by considering minus 1, minus 2, minus 3, how will be the graph of h of x between 0 and 1? Yes, between 0 and 1 the graph would be 0, so it would be 0 to 1, right? Now when you move from 1 to 2, how will be the greatest integer value of mod x? Mod x will be positive, so it's same as that of greatest integer value of x. Greatest integer value of x lying between 0 and 1 would be starting from 1 up to 2, it will be 1. So it will be a line including 1 but not including 2. Now again, between 2 and 3, how will be the mod x function? Mod x will be x, and step of a number which lies between 2 and 3 would be 2. It's a including 2 but excluding 3, right? Similarly between 3 and 4, by similar argument, it would be including 3 but at 4 it will have a discontinuity. Now we are able to easily draw the graph of h of x on the positive side. What can you say about the graph on the negative side? Yes, between 0 and minus 1, mod x will be minus x. So that will also be a number that lies between 0 and 1, and their greatest integer value will be 0. So here it would be not including 1, but from 0 to minus 1 it would be 0. Now between minus 1 to minus 2, the modulus value would lie between 1 to 2, and therefore the greatest integer value of that number which lies between 1 and 2 would be 1. So it includes 1. And up to 2 it will be, and at 2 it will have a discontinuity, right? So again at x equal to minus 2 we have a open circle, that means the value is not included here. How will be the number that is between minus 2 to minus 3? Between minus 2 to minus 3, modulus value would be minus x, that means that number would lie between 2 and 3. For a number which lies between 2 and 3, how will be the greatest integer value? Yes, it would be 2, and up to minus 3 it would be a constant 2, right? So if you observe here, h of x is having jump discontinuity at x equal to minus 2. Clearly if you look at limit x tends to minus 2 minus h of x, that is on the left side of minus 2, how will be the function limiting value? Yes, it would be 2. Now at minus 2, how will be the right hand limit? Limit x tends to minus 2 plus, that is on the right side of minus 2. The functional value would be h of x would be 1. And not only this, what is h of minus 2 value? At minus 2 the function will take a value of 2. So if you clearly observe this, h of x is left continuous at x equal to minus 2 but not right continuous. So finally h of x is having a jump discontinuity. When a function is discontinuous, clearly derivative is non-discussable, derivative does not exist. Therefore, h of x is non-differentiable at x equal to minus 2. So how much is the h dash of minus 2 value? It does not exist, right?